So now we have the joy of the keynote speaker. It is my great pleasure to welcome Mike RONAN from Department of Environment Science. Mike is the busiest man I know, but he always has time for people to talk about really important things in the landscape, like wetlands, those damp spots. No one talks about them quite like Mike. I could go on again about Mike's credentials, but I'll let you read them for yourself. And would you please give a very warm welcome to Mike RONAN.
Okay, so there goes my whole presentation. You've seen it before I even open my mouth. First of all, I would just want to, it's just such a privilege to be speaking here today, to see so many fabulous faces, many of whom I already know, but to be here to talk about what is my passion, wetlands, is tremendous. But I'm not going to be fully talking about wetlands. It's going to be about the catchment itself and about the Pumicestone. And I want to try and share with you where the Pumicestone sits relative to kind of other catchments in Queensland. So where does it sit, and also why is it so important? Why has it got the features it's got? Because as we've heard from the previous speakers, everything we get from the catchment comes from the way the catchment works. It's the lifeblood of our system, and basically that's what I'll be going through. But first of all, I just want to acknowledge the traditional custodians of the land on which we meet, the Cubby Cubby and the Jindabarra, and to pay my respects to their elders, past, present, and those emerging. They've done an excellent job in looking after this absolutely beautiful catchment, and I hope that we'll do justice to the catchment moving forward together. So this is also the 50th anniversary of the Ramsar Convention. It was signed in Iran, in Ramsar, the place, in 1971. So 50th anniversary. I won't be around for the next one, so I'm going to make the most that I possibly can out of it, because it's going to be a great year, and what a wonderful way to actually start the year in looking at with this Pumicestone convergence. So just jumping into wetlands and catchments, they're very different throughout Queensland. I absolutely love this state. It's got so many different features, so many different catchments, so many beautiful landscapes. So right from the very top, in the wet tropics, we've got catchments that move, where water moves very, very quickly. So that water hits there, lots of water, moves very fast, and creates these absolutely beautiful landscapes, very green, gorgeous, lovely catchments, and they all have their own specific characteristics. But we've also got these absolutely stunning systems out west. So the Channel Country, down in southwest Queensland, we've got beautiful places like Carrawinja National Park, which is another Ramsar site. And these systems are what are called boom and bust. So you get absolutely, the place can be dry for 4 or 5 years. All of the fish and invertebrates in that all just kind of retreat back to the water holes. And you get the seed banks. Basically, it looks desolate. And then water comes through, and you get these absolutely stunning systems here. They just burst to life. We've also got these systems up here, which are called dry floods. So what happens here is you can see the flood going down the middle, and then it's completely dry on either side. So the water can actually fall 100 kilometers, 200 kilometers to the north, and then go straight through. So very, very different kind of a catchment than what we're dealing with here in the Pumicestone. And of course, a lot of our catchments then also make it down to the coast. So it's a continuum from the catchment right down to the coasts. And we've got some beautiful, beautiful estuarine systems like Norm had indicated a bit earlier on. So we've just got these absolutely beautiful, very, very extensive estuarine systems all the way along the coast. So these are all completely connected to our catchments. And of course, they're very, very productive. So these bottom ends of the catchments have got all kinds of critters living in them because they're actually getting the nutrients not just from the catchments, but also from the sea itself. So very, very productive systems with absolutely wonderful amounts of wildlife in them. The systems we've got here in southeast Queensland are quite different. These systems here, they are not necessarily in the Pumicestone, but these are these Wallam systems. They're on sands, and they've got very specific characteristics. They're quite distinct, and they're not that common all over the world. So one of the things you'll notice with them is that the water a lot of the time is tannin stained, and we're all recognize that in the Pumicestone catchment in Onbrivey. And they have that kind of brown tannin stained water. The other thing about these systems here is that they're not very productive. They're actually nutrient-wise a bit limited. So the reason why that's really important is that if you add a lot of nutrients to them, they kind of do strange things sometimes. So they're also very porous. So these systems down here, not very nutrient rich and very, very porous in terms of the actual sand. The sand water will run straight through it and carrying nutrients and that with it. So it makes these systems here a little bit more prone to kind of, I suppose, water pollution and so on. And it's naturally just, that's how the systems actually are. So we heard a little bit earlier on about the fact that you cannot manage a catchment unless you actually manage it as a whole. You have to actually manage it from the top right through, because water moves all the way through that catchment. It gets recharged up the top, so the water gets into the actual ground up here, and then as it comes down through the catchment, it comes out at various different places, until finally water still flows down the hill and ultimately comes out both on the surface and underneath, all the way through the catchment itself. So when you're looking at the Pumicestone, you're looking at it not just from what's on the surface, but what's actually popping out as water in the actual system itself. And remember, you're dealing with a sandy system, so that's actually a big, big driver in the Pumicestone will always be the water that actually comes through the ground and from the ground. That actually keeps this system basically in the kind of a catchment that it is. But of course, you don't just have to look at the water, because there's connections everywhere. This whole landscape is connected. So you can get local little connections of fish and other creatures within small kind of areas of the catchment. But you also get birds and other creatures moving around between different parts of the catchment. So you've got connections there as well. You've got connections of the biological and the chemical processes that are going on. You're getting nutrients moved around, you're getting nitrogen, you're getting phosphorus, you're getting all kinds of other chemicals moved around. Then you also have the movement of the aquatic system and the terrestrial system. So you're getting plant roots taking nutrients up and so on. And then during times of floods, you actually get the bigger connections happening. And of course, that area there is connected to the broader catchment. So it's a very complex system. And you've got connections everywhere. They're not all aquatic connections. Some of them are actually chemical and physical connections. And all of that momentum of the catchment basically gives rise to all of the values that we get from that catchment. So everything we get from that catchment, whether it's the houses we live in, the farms that are producing our crops, the fish that we've got, the tourism, the biodiversity, it all relates back to how that catchment works. So we heard some fabulous stories about the First Nations use of this land, and ultimately it's the same principle. It was that catchment operating with the bits and the processes and the parts of the catchment that actually give rise to all of the values and services we get out of that catchment. So this is just another way of putting it. So you've got the bits in the landscape, the components, and then you've got the processes. And I like to think of processes. I could put a very nice scientific thing of what a process is, and I could give it a lovely definition, really nice scientific definition, put a lovely reference on it, and people can quote it in research papers. But processes are stories. That's effectively the best way of describing processes. They're stories. They're actually how things move, how things operate. That's actually what processes are. So you've got the parts of the landscape, and as Europeans, we're great at dealing with the bits. We don't deal with the processes very well, and the processes are stories. And it's those processes and the components that basically give rise to all the services and values that we put on the system. This is just kind of a bit of another way of looking at it. So we've got all those bits in the landscape, and for something like provisioning of water, and we all benefit from that. So, and the other thing with that is that if you look at the system like this, if you start stuffing up some of the bits here, you'll end up affecting the actual processes you get. And I think that's very similar to what you were referring to, where if you actually change fire regimes, if you change some of the processes here, you change the way that the plants grow, you change the way and you get different services, and you can land up with lots of problems. So it's very, very important in terms of managing catchments that you're constantly thinking, if I do this, what service am I actually going to affect? Because it's all interconnected. Lots of different services that we get from the catchment. Virtually everything we do is a service that the catchment provides. And when you look at the actual catchment like that, it becomes a living thing, and it actually becomes, everywhere you go, you're looking at, you know, how do these services, what am I doing? How does it affect those services? This is a whole of catchment management approach that we've developed in the wetlands program. And it seems, this is actually where most people come in. The minute you start talking to a person, they start basically saying, well, what's the purpose of your project? We're all very directed in terms of the projects we do. You know, we've got a blue carbon, or we've got a project on fish, or we've got a project on whatever. But really, we should be starting up here, and that's what I love about the work that's actually been done in the Pumicestone catchment. The group that works in here is that they actually want to understand how the system works first, then what services do you get, and then you come in with your drivers. But if you actually start here, everybody is on the different pages. So you got a person looking at it from a fish point of view, you got a person looking at it from, you know, a development point of view. If you start up here, understand how the system works, recognize the services we get, then management of the catchment is a lot easier. So that's basically what we kind of push and promote, and it's been used in quite a few places around Queensland. So just coming back to the catchment and water flow, as I say, it's complex. We're quite good a lot of the time in looking at the water as it moves across the surface, but there's all kinds of things happening in the recharge space and in groundwater. So you can actually get recharge at various different places in the catchment, and then it can come out as springs. A lot of the time, what happens is that you get a really big flood event, and then you'll actually have water kind of popping out at various places that it hasn't been before. So it's recharged up somewhere, and then it kind of pops out in various different places. Was we did a walk in the landscape up in the Saltwater Creek up in Cairns. And I don't know if you know Cairns very well, but on the way to the airport, there's a fairly major kind of development in a very enclosed catchment. And in the past, it was all sand dunes. And what they did was they filled in the sand dunes with basically landfill. So it's all landfill, and then, so in the swales, in the actual dunes, you had landfill. But what happens is there, when it rains really, really heavily on the hills around, the water pops out just the way it used to, but it now pops out in people's houses and basically comes up through their backyards. And so the land is still there, the water is still doing what the water is doing, but we've actually put things in there that probably might not and shouldn't really be there. So this can happen, and sometimes the recharging and the water coming out here might not happen every year. It might actually take quite a few years before it re-establishes. So we've got lots of different aquifers underneath the ground. We've got perched ones, we've got confined ones, and all of that is something that we are constantly playing around with and moving water around the catchment. So it's quite a complex system. And to manage wetlands, you actually have to understand what the water flow in and out of those wetlands are. So I'll just give you a little bit more in terms of catchments, and then we'll get into the walk on the landscape process. So as I said, you have to understand water and water flow in a catchment to really understand how a catchment works. And the kind of things that really drive that are things like geology, soils and sediment, and the plants and the animals. So they all affect how the water moves, and trying to understand that is pivotal to understanding the catchment. The water itself then, of course, is affected by that landscape. So the water quality, the nutrients, the cycle of the plants and animals are all affected by that water and the way it moves in the landscape. So it all seems really, really hard to do. It's like, well, we'll just walk away. This is just too hard to try and put it all together. So what we started about 8 years ago, is a process called Walk in the Landscape. And the reason we call it Walk in the Landscape is because you virtually walk the landscape through the eyes of the people who actually live in the catchment. So many people in this room were involved in the Walk in the Landscapes we did. And it's a scientific process where we systematically walk through different parts of the landscape, and we try to understand how the system actually works and how it moves. And the reason why we don't try and do it sitting in Brisbane with a whole bunch of data sets is because you cannot fully appreciate how that landscape works without the locals. You've got to get them involved. If you don't get them involved, you will get it wrong. I've run over 100 of these workshops all over Queensland, and it doesn't matter how much I pour over that data, I will always get it wrong until I actually hear people telling me how it actually works. So it's a very effective system to try to understand how the water does move in it. So we basically, the other thing about it is that we put no value judgment on it. So when somebody kind of says, oh, you know, that person shouldn't have built that over there, we don't ever bring any of that in. We just tell the story as it is. How does the actual system work? And so that's what we're looking at, is we're looking at the natural hydrology, we're looking at the terrain, and we're also looking at the modified features. So any roads or railways or anything like that, we include all of that in it to get us an idea of how the system is actually working. And this is just some of the people. Some people might recognize some of the people in the room here. We did it, one of the very earliest ones for the Pumicestone. So right through the whole lot, looking at culverts, looking at roads, trying to figure out how the actual system works. We've developed catchment stories now. This is one of the outputs. We developed catchment stories. We've got over 50 of these. It's been my, basically, life for the last probably 7 or 8 years. I've been all over the state. And it's been a absolute privilege to catch up with communities from everywhere from the Lake Eyre Basin through to Cape York, right down to the Gold Coast and everywhere in between, to kind of capture these stories of basically water movement. And of course, the Pumicestone is in here. So I'm going to actually get a really easy mark, because the last 10 minutes I'm going to be able to sit down and put a video on, but hopefully the video will work, because otherwise I'm going to be doing a dance or something. So I suppose catchment management then, from that, when you know how the catchment works and you know what the services and values you get, then you come down to best management practice to make sure that you can actually manage it properly. And fortunately, we've developed lots of very good tools. And the forum today and the workshop today, or the next few days, is so important for trying to come up with those technologies and advances in terms of managing our catchments. I'm going to end this bit of the presentation then with just a little bit of a talk about Ramsar, what it actually means. And I'll turn these little bobbin things off, because they can kind of make you feel a bit sick. So Ramsar is all about the wise use. It's a wonderful concept. It's a lovely, lovely approach. It's not about locking things away. It's about living in the landscape. It's about using wetlands wisely, not stuffing them up, not killing them, but actually getting, I suppose, being able to work in harmony with them. And the people who first came up with the Ramsar, people who started the whole process, were very visionary in what their thinking, because it is about wise use, and it's about wise use of all the wetlands that we've got in the state, because of the wonderful values that they actually provide to us all. But there's also the listing of wetlands of international importance. Now, when it comes to Queensland, we only have 5 internationally important listed wetlands. So the Pumicestone Passage and the Pumicestone Catchment, or parts of the Pumicestone Catchment, are part of the Moreton Bay Ramsar site. So the other areas, I just spent the last 2 days up in Garry and or Fraser Island, and the Great Sandy Strait, another really super Ramsar site. We also have Shoalwater, which is one of the wildest places in the whole of probably Australia. Very, very wild area. You wouldn't want to go in there, though. You might get blown to pieces. It's a military area. You've got Bowling Green Bay, and then the only inland Ramsar site we've got in the state is Carrawinja Lakes, which is right down here in this. And it's had some fabulous rain over the last 2 years, and it's just looking stunning at the moment. So the Pumicestone is actually in Moreton Bay, part of the Moreton Bay Ramsar site, to say one of the only 5 internationally important wetland sites in the whole of Queensland, and only 66 in the whole of Australia. So it's a pretty high benchmark, and your little catchment, because the Pumicestone is a little catchment, is actually right up there in terms of being part of that site. There are 9 criteria to be listed as a Ramsar site. Unfortunately, one of them is not cultural values, and there's been a big push to try and change that at an international level. But there are 9 criteria, and Moreton Bay ticks every box. So you only really have to have 1 criteria to actually have a listed Ramsar site. Moreton Bay ticks all 9. So that is very, very rare, and gives you, again, when you're thinking about the Pumicestone, just be aware of just what a special place you're actually living in. There's a lot of paperwork associated with Ramsar sites. There's an awful lot of obligations associated with it. We have to maintain the ecological character of the site. We have to make sure that any developments or any kind of things that might affect that ecological character are notified at an international level. So it's a very high benchmark, and we are actually held to account in terms of the Ramsar site. And the site itself has got all of these services and values. These are the actual things that it's got in terms of what it actually meets. But what I'm going to do is, rather than go through all of this, I'm just going to see if we've got the video of the Pumicestone catchment that we developed through the Walk in the Landscape, and that actually explains how the catchment works and also goes through the actual values associated with the area. So I will see if it works. And it's narrated by Ranger Tim. I don't know if any of you remember Ranger Tim from Totally Wild, but he's the one who narrates it. And unfortunately, he had a can of Coke before he started, so we had to take a lot of takes while he was basically, don't drink Coke before you do some kind of a narration or something. It doesn't work. Are we ready? Or I'll have to do
Catchment is located north of Brisbane. It contains significant features such as Pumicestone Passage, which is part of the Moreton Bay Marine Park, and internationally important Ramsar site, Bribie Island, the D'Aguilar Range, and Glasshouse Mountains. The sub-catchments that make up most of the area include the 6 Mile, Ningi, Beerburrum, Lower Ilumba, Bullock, Glass Mountain, Tipragargan, Coonarin, Melamcoochen, Halls, Bells, Lamara, and a number of smaller coastal creek systems, as well as Bribie's sub-catchments. The Pumicestone catchment provides a wide range of land and water-based recreational activities that support local lifestyles. National parks and forestry reserves around the Glasshouse Mountains and Bribie Island are well known for their protected bushland areas and are important for tourism. To effectively manage this beautiful area, it's important to understand how water flows in the catchment and how it can be affected by land use and management practices. Prior to development, tall open forests of scribbly gum and blackbutt dominated most of the mainland catchment areas, and wetland forests of paperbarks, mangroves and heath grew on the coastal plains. This vegetation slowed water coming off the land, retaining it longer in the landscape. Today, more than half the catchment has been cleared to provide important rural industries such as forestry plantations, pineapples, strawberries, turf farms and animal husbandry. The area is also home to a population of more than 60,000 people. Residential and industrial developments can also modify water flow. These developments can change the shape of the landscape and add impermeable surfaces, such as roads, which lead to increases in runoff. While roads, railways and creek crossings are essential, they modify the flow of water and may act as barriers, redirecting water through single points or culverts. Off-stream dams and other similar infrastructure can also change the natural water flow patterns. When it rains, much of the water flows across the surface of the land into local streams and eventually into Pumicestone Passage. The remaining water either sinks into the ground where it supports a variety of terrestrial and aquatic groundwater dependent ecosystems, or it's used for other purposes. The Glasshouse Mountains and the D'Aguilar Range have relatively steep slopes, which create the potential for increased runoff that may lead to flooding in areas where the floodplain has restricted channels and gullies. Groundwater comes to the surface in areas where permeable weathered basalt rock meets a less permeable underlying geology. Groundwater may also discharge from fractured rock aquifers, typically along foot slopes and drainage lines in the steep slopes. This can cause landslips. Moving from these steeper slopes, the restricted channels and gullies eventually flatten out to form waterways that meander across the coastal lowlands, with the exception of Beerburrum, where the floodplain is constricted due to the underlying rock formation downstream. These creeks and rivers pass through alluvial areas which have formed over thousands of years and are made up of silt, sand, gravel and other materials deposited by rivers. They store and release water like a sponge. Groundwater generally seeps from alluvia into nearby streams, prolonging the time they are in flow. For example, paperbark swamps act as major recharge areas in coastal and subcoastal floodplains, with trapped water soaking down into the groundwater. Water is released from the subcatchments into the Pumicestone Passage in a variety of ways, depending on the catchment and the rate of flow. Each creek system is complex and dynamic and reacts differently depending on a variety of influences, such as the level of the groundwater aquifer, the tides, and even the wind direction. For example, during high flows in the lower southern catchment, water overtops the channels and spreads over the floodplain, joining Ilimba, Bullock and Ningi creeks. Glass Mountain Creek has many different sized channels, which eventually merge. At other times, the lower catchment waterways are slow and meandering, within channels or forming many wetlands. These channels eventually become estuarine because the freshwater mixes with marine water before flowing into the Pumicestone Passage. The Pumicestone Passage is one of the few barrier estuaries in Australia. It has extensive mangrove forests, seagrass meadows, intertidal sandbars and mudflats, which provide valuable habitat for fish, dugong, turtles, crabs, oysters, juvenile prawns and a wide variety of local and migratory waders and shorebirds. At the lower end of Tipragargan Creek, also known as Hussey Creek, there is almost no water movement from tidal action. This is because two different tides meet. Tripconey Bight, a wide estuary area beside the lower reaches of Tipragargan Creek, has formed due to this very low energy area. Every drop of rain that falls in the Pumicestone catchment has its own story, its own journey from landfall to the passage, and finally the ocean. Drops fall, join, and flow together down the catchment or through the ground. Together they shape and nurture the landscape and intertwine with the stories of the plants and animals, including humans, that share the catchment.
So I'll just finish off just some last bits about the catchment. I think that kind of summarises it fairly well. But just some, I suppose, things about the catchment there, and looking at the catchment story. That very undulating landscape that we've got here, that's partly formed by sandstones. There's a lot of sandstone in this particular catchment. And the lower parts of the actual, I suppose, parts of the system are where that alluvium builds up, and that's why there's so many wetlands in the actual catchment itself. So that water can't really get into the sandstone, so it sits in that those alluvial areas. Those areas as well in the catchment have got threatened species in them. So we've got the honey blue-eye. And one of the things that I think has happened, and I'll be interested in the conference over the next few days, is that I don't think they have been surveyed for a very long time. So exactly how well the honey blue-eyes are doing in the catchment is, I think, a question. That's a few other things. That area around Tripkinny Bight, that area which is that amphidromic zone, it's called an amphidromic zone. That's where you've got the water coming from the two sides. And basically, that is a dead zone. So when things come out there, they don't really wash out of it. You got one very, very similar up in Great Sandy Strait. And that's where things like the whales get stuck and the dugongs get stuck because they kind of come in and they don't know where to move, so they actually get stuck on those particular areas. So that's the area where the skids are, and it's because those tides are coming from two different directions. So there's some quite unique features in here. This is also one of the biggest sand barrier passages in Queensland. It's the second biggest. It's one of the biggest probably in the whole of Australia. So again, that whole feature of having a sand island and then an actual passage is quite rare as well. So that feature is not a very common feature. There's lots of other bits and pieces that we've learned since this story was done. We did this in the form of a video. We don't do videos anymore. We actually do it using Esri map journals. And the reason we do that is so that we can update it. And there'll be so much new information that actually comes across over the next 2 days. We don't have proper representation of First Nations information in here at all. We've really started to change that whole mode of operations. So while the video is accurate in terms of some of the information, the problem is that we can't continue to keep updating it. So the technologies we use now are much better than probably the video that we had originally. So this was always one of the pioneering catchments in terms of the group that actually manages this area. So they're always the first cab off the rank. But then we learn from that, and we have to come back and redo it again. So hopefully sometime in the future, we'll be able to do another walk in the landscape where we'll be able to incorporate more information and update this into the future. So thank you.